For this video, we're working on bubble sort. Bubble sort. So we'll be using an example of marks from a certain class. We have an array of marks. Student got like 30 out of 100, 44. We have 60, 23. We have 44. I'm just putting in random numbers out of 100, 88, 66. Let me put maybe 52 here. And so the way bubble sorting works is we traverse through our array multiple times, and for each pass we take a pair of integers. We keep switching each integers, comparing it with every integer close to it. So I'll just show an example of how the first pass would go. So we have the first pass through our array. So this is how the first pass would go. We'd start with at index 0, where we have 52. Compare index 0 with the next index. So let me say if this is I, then compare I with I plus 1, which is 52 compared with 30, right? So we see that 52 is greater than 30. So these two integers will switch. Then we'll have 30 come here and 52. Now this array of two integers is sorted, right? Then the next thing is we compare. Since 52 is now at index 1, where 30 was, we compare 52 with 44, right? If 52 is greater than 44, then we'll switch them, but if not, it stays the same. Since 52 is greater than 44, then we can have 44 right there. Now we have 52 at index 2, 0, 1, 2. Now we compare 52 with 60. If 52 is less than 60, it stays as it is, but if it's greater, then we switch. But since 52 is less, then 60 stays where it's at, right? Now we're comparing 60 with 23. If 60 is greater than 23, we switch, but if it's less, then it stays the same. Since it's greater than, we switch. 23 comes here, and then 60 goes forward. Now we compare 60 with 44. The same thing we did for the previous ones. Since 44 is less, 44 will come here, and 60 goes forward. Now compare 60 with 90. 90 is greater than 60, so it stays as it is. 90 compared with 88. 88 is less, so 88 switches with 90. 66 compared with 90. 66 is less. Now we switch the two. 66, 90. So now we see that the entire array is not sorted, but at least we know the last integer is the highest, right? We know 100% that the last integer is sorted. Now we can say for the length of this array, at least we can deduct the last number minus 1 and then focus on this one until the entire array is sorted, right? I'll start writing the code. I think it'll be easy to understand how the next passes will work. So this will be multiple passes traversing through our array until the entire array is sorted. So our function will be, let's call it bubble sort. We have bubble sort, and our inputs will take an array of marks, right? So the similar thing we did for insertion sort, let's initialize n as the length of the array marks. Now that we have our length of the array, what we'll do is we'll write our first for loop just to traverse through every element in our array for I in range n, right? After we traverse the first time through our array, now what we have to do is write our second for loop for j in range from 0, going from 0 to n. So we have to deduct I since we have index I already, n minus I, and now we go into the last element in our array, and since we're starting from 0, remember it'll be n minus 1, so minus 1, right? So now that we have done this, we can say if we start with index 0, let's say index j marks, if marks at j, so if marks at j, say j is at index where 30 is, where mark 30 is at index 1, right? If marks at j is greater than 44, which is marks at j plus 1, mux j plus 1. If it's greater than that, then what we do is we switch, right? We switch j. This is what we did for our first pass. So what we'll do is we switch j, mux j, we switch it with mux j plus 1. And we do this by saying it's equals to mux j plus 1, comma, mux j, right? This should sort our array, and after this we get out of the for loop and return mux. Just going through it again. See, we have our function bubble sort, where we have our input as mux and the length of the array n, right? For I in range of n and for j in range of from 0 to n minus I minus 1, if mux at j at index j is greater than the next index, which is j plus 1, then we can say switch mux j with mux j plus 1, and we return our array mux, right? So to check if our array is actually, to check if our function is working, we'll take the array we created before. We can play around with any array just to check it, but let's just start with this one. We know it's not sorted, and call our function bubble sort and see if we can get a sorted array from this. Perfect. So we have 23, 30, 44. See, even if we have repeating elements in our array, it still brings them together as sorted integers in the final array. So 52, 60, 66, 88, 90. So now we have our sorted array. So this is how bubble sorting works.